This is section 4.5 in Algebra 2, solving by factoring. So in order to solve by factoring, the equation must first equal 0. If it's set up as f of x equals the equation, we make f of x 0 and then solve. So we're going to follow our steps to factor. So that's taking out a GCF, or factoring by grouping, or using one of the special patterns, or solving given one of the factors already. Set each factor equals to 0 and solve. Other ways they might phrase would be find the zeros, find the solutions, or find the x-intercepts. So our first problem here, to solve by factoring, I noticed that I have a GCF. So 5x can be taken out of all three of these things. So when I divide it out, I'm really factoring it out and putting it on the outside. So now 5x cubed over 5x is x squared. Negative 40x squared over 5x is negative 8x. And 80x over 5x is 16. So I can't factor 5x any further, but I can factor x squared minus 8x plus 16. This is 16 is really 4 squared, or negative 4 squared, and negative 4 and negative 4 is negative 8. So this is x minus 4 squared, or x minus 4 times x minus 4. So now I'm going to set each of these factors equal to 0. So 5x equals 0, and x minus 4 squared equals 0. So here when I divide by 5, x is 0. Here, I square root both sides, so x minus 4 equals 0, and add 4, x equals 4. So my solutions are x equals 0 and x equals 4, and x equals 4 is actually a repeated solution because it was a factor twice. So you try this problem, pause when you're ready to see the answer, hit play. All right, so we start out by taking out, oops, I forgot to write that, 3x squared. And our solutions are x equals 0, x equals negative 6, and x equals negative 3. So our next one, I don't have a GCF that I can take out of all of these, because the only thing I can take out of these are x's, but there is no x on 20. So this has 4 terms. So I'm going to try to factor it by grouping. So out of the first 2 terms, I could take out x squared. So x cubed over x squared is x. Negative 5x squared over x squared is negative 5. Out of the second 2 terms, I could take out a negative 4. So negative 4x over negative 4 is x, and 20 over negative 4 is minus 5. So it does in fact work to factor by grouping because we do have matching factors here. So that means this is x minus 5 times x squared minus 4. And this can be factored further. So x squared minus 4 is x plus 2, and x minus 2. So now that we are fully factored, we could set each one equal to 0 and solve. So we get x is 5, x is negative 2, and x is positive 2. All right, you try the next one. Pause. When you're ready to see the answer, hit play. So this again could be factored by grouping. Even though it's set up as f of x, we could treat that as a 0. So now when I group, I get x plus 2 times x squared minus 64. That could be factored to x plus 8, x minus 8. So all 3 of my solutions are x equals negative 2, x equals negative 8, and x equals positive 8. The rational root theorem says that if we have a polynomial and it has integer coefficients, right, no decimals, no fractions, then every rational solution of f of x equals 0 has the following form. It's going to be p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. So for all of our polynomials, if it's going to have a rational solution, it's only going to be able to come from a list where it's a factor of the constant over a factor of the leading coefficient. So let's start by making a list of the possible rational zeros of the polynomial. So the constant is 18, which means it's going to make a list like this, right? 1 and 18, 2 and 9, 3 and 6. And our leading coefficient is 1, which is just 1 and 1. So I'm going to take every number here and put it over 1, which means it's not going to change. It's just going to stay that number. So it's nice when the leading coefficient is 1. So since this could have been positive or negative to multiply to get our 18, it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. For the second one, my constant is negative 4, so we'll just go right 4 because it's going to be positive and negative. So it could be 1 and 4 or 2 and 2. Our leading coefficient is 5, so that could either be 1 or 5. So I'm going to take each of these and put them over 1, and take each of these and put them over 5, because it's P over Q. So that's plus or minus 1 over 1, plus or minus 1 over 5. Plus or minus 2 over 1, plus or minus 2 over 5. We already took care of 2, so plus or minus 4 over 1 and plus or minus 4 over 5. So this is our list of possible rational solutions or zeros of the polynomial. So you go ahead, try the next one, list all possible rational zeros of this polynomial. Pause when you're ready to see the answer. Hit play. All right, with a leading coefficient of 1 and a constant of 30, that'd be plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. The reason we make this list is because if we want to find all of the solutions of a polynomial and we cannot factor it with any of the methods that we know, we're going to have to guess and check to find out what really is a solution until we can get it to a point where we can factor it. So for this problem, we have a leading coefficient of 1 and a constant of 20. So if I make my list, looks like that's all the possible numbers. So my possible answers are plus or minus 1, 2, 4, 5, 10, and 20. We're going to start with our positive 1, see if it works. If it doesn't, we're going to move on to negative 1. We're going to go through our list until we find a 0 that works in this polynomial. So I'm going to do this using synthetic division. I'm going to take 1, negative 8, 11, 20, right? Not missing any terms. And let's say we start with a positive 1. So 1 times 1 is 1, so we get negative 7. 1 times negative 7, we get 4, and that's 24. So that means positive 1 did not work. So next I would move on to negative. So we have negative 1 is negative 9 there, that's positive 9, positive 20, negative 20 is 0. So negative 1, x equals negative 1 is one of my solutions. I'm left with 1x squared minus 9x plus 20. X still equals 0 like it did before. This is factorable. The two things that multiply to 20 and add to negative 9 are negative 4 and negative 5. So you get x minus 4, x minus 5. So I can say x minus 4 equals 0, x minus 5 equals 0. So x also equals 4, and x equals 5. So we have 3 total answers here. the original one we got to get it down to a remainder of 0, and the last two that we got by factoring. Notice, -1 was in our list, +4 was in our list, and +5 was in our list. So all of those would have made 0 had I tried to do synthetic division. All right, let's do another one together. So we have 14 or -14, so that's 1 and 14, 2 and 7. Much shorter list this time. So ±1, ±2, ±7, ±14. All right. So let's say we tried +1. We have 1, 3, -5, -14. So we get 1 is 4, 4 is -1, -1 is -15. So I could try -1, but it looks like I'm going to have to go a little bigger to try to get bigger number at the end, right? I'm not getting much bigger here. So let's say I try 2. Right, we know positive ones out. So you don't have to exactly go in order of what the numbers are. You don't have to do every positive, every negative. But it's also helpful to do that if you're unsure. That is 10, that's 5, that's 10, that's -4. I'm not going to jump up to 7. I'm going to try -2. So -2 is 1, -2 is -7. Oh, +14 is 0. So far we know x equals -2 is a solution. I'm left with x squared plus x minus 7. Now, I can't think of any two numbers that multiply to give me -7 and add +1. So what this tells me is my answers are probably not rational, which means they're not going to actually come from this list. The directions were to find a real solution. So I'm looking for numbers that could have square roots in them. So I'm going to try to do this by the quadratic formula, right? I can't complete the square because b is not even, but I can use quadratic formula. So remember, our first step is b squared minus 4ac, which was 1 squared minus 4 times 1 times -7. So this is 1 plus 28 or 29. So the quadratic formula was negative b plus or minus the square root of b squared minus 4ac all over 2 times a, which means my other solutions are -1 plus or minus the square root of 29 all over 2. So it's very possible for us to get answers like this after first finding our first integer solution. All right, you go ahead and try this one. Pause when you're ready to see the answer. Hit play. All right, let's check our answer here. We have possible solutions of positive or -1, 3, 9, and 27. I tried other ones, but I'm just showing you the one that works. 3 works. We got the remainder of 0. I put x squared plus 2x minus 9, which when I put into the quadratic formula, I get -2 plus or minus 2 radical 10 because the square root of 40 is really 4 times 10. Square root of 4 is 2. Reduce everything here by 2. We get plus or -1 plus minus square root of 10. And our x equals 3 from the beginning. Everything we've done so far is x to the 3rd power, which means we had 3 solutions. But now I'm looking at x to the 4th, which actually means I'm going to have 4 solutions. So I'm still going to start take everything away and I'm going to make my list. This is a nice easy one because it's just 9. So +1, +3, or +9. So let's say I start with +1. So we're not missing any terms. 1 times negative 21, 1 times 19, 53, and then, so 1 does not work. So we could try negative 1. Negative 1, negative 23, that's for positive 23, positive 63, negative 63, negative 9, and now positive 9, 0. So that one works. So I'm still left with a cubic, and it cannot be factored by grouping. So what I'm going to have to do is keep trying numbers from my list. I already know 1 doesn't work. I could try negative 1 again, because it's possible that negative 1 was repeated solution. But since I already know my answers, I know I'm going to go ahead and try positive 3. And now I'm actually going to use these numbers. Right? I want the reduced one. So we get 3 there, we get negative 60 there, and we get 9 there. So now I'm left with x squared minus 20x plus 3. And this remaining can be solved with the quadratic form. B squared minus 4ac, 400 minus 12 is 380. That's going to be negative b plus or minus the square root of 388 all over 2 times 1. Extend, but we're going to make it a little bigger. So this is going to be positive 20 plus or minus. So 388 is really 4 times 97. So the square root of 4 is 2. Leave 97 inside, which means all of this can be reduced by 2. And then we have our other ones that work. We had x equals 3 work. And from up above, we had x equals negative 1 work. So those are our 4 solutions to this 4th power. All right, then we have a 5th power, which means I'm going to have 5 total answers. So making my list, we're looking at number 36. All right, we will likely never get to these bigger numbers. It's likely going to be more in the beginning. So let's say we start with positive 1. So we're not missing any terms. All right, it looks like we get a remainder of 56, so that's not going to work. So let's say we try negative 1. And we get a remainder of 0. So far, make a list over here, x equals negative 1. So now my next ones I'm going to try are from this set. And what if I tried negative 1 again? So using 1, 2, negative 23, 12, and 36. And we get another remainder of 0, which means x equals negative 1 is a repeated solution. I still have a cubic, So now I'm going to try another number. I'm actually going to skip over 2 right now. I'm going to go straight to 3. So let's try 3. And look at that, 3 works. So we're left with, all right, let's put x equals 3 here. We're left with x squared plus 4x minus 12, and this is actually factorable. The two numbers that multiply negative 12 and add positive 4 are x plus 6, x minus 2. So that means we also get x equals negative 6 and x equals positive 2. Oh, look at that. I could have done a 2 there as well, and it would have worked. All right, so those are our 4 solutions, even though x equals negative 1 was a repeated solution. So you go ahead, try the last one. There should be 4 answers. Pause. When you're ready to see the answer, hit play. All right, so we had a whole list of possible solutions. Negative 1 worked. We got a remainder of 0. I used the 1, negative 11, 16, 84 next. Negative 2 worked with a remainder of 0. I'm left with x squared minus 13x plus 42, which factors to x minus 6 times x minus 7. So my total solutions are x equals negative 1, x equals negative 2, x equals 6, and x equals 7. And that is section 4.5.